Hi everyone, welcome back to Pine Hollow Auto Diagnostics. Today we're doing a little tune-up on my own 2002 Suzuki XL-7. It's driving fine, but I've noticed that on the highway it kind of lacks power. It used to be more peppy, it's just kind of sluggish, and the fuel economy, usually I can get 22, 23 miles per gallon. Now it's barely getting to 20 miles per gallon. So what is going on? Something is slowly making this thing more sluggish, less efficient. Horsepower is down a little bit. So what I want to check right now is ignition timing. So this system, it's a coil on plug design, and the base ignition timing is adjustable by rotating this camshaft position sensor on bank 1. Okay, so if we look up the procedure, this is a OEM procedure. Warm up the engine, hook up the scanner, and switch it to fixed spark mode. That will set the timing to 5 degrees before top dead center. Then using a timing light connected to the primary wires on the ignition coil number 1, you point it at the harmonic balancer, and we should see that little mark at 5 degrees before top dead center. So let's do that check and go from there. Alright, start it up. And on our scanner, from the actuator tests, we go to fixed spark. So warm up the engine, engine's idling. Okay, so it cooled down a little bit, so it'll warm back up. The cool thing is, you see the timing lights connected to the ground wires, the 3-wire coil, feed, ground, and the low voltage trigger signal. And the timing light works off of the current through the primary winding. So you don't need a secondary ignition lead to have your timing light work, which is pretty cool. So we can aim it down there, and you can see the white mark. Hopefully you can see it. It's to the left of the marks on the timing cover. So once this engine's warmed up, let's just do data display. And the fuel trims, I notice, are a little high. They're about 10% long term at idle. So if we go to custom data, RPM, desired RPM, IAC, engine coolant temp, and let's do long term on bank 1 and 2, and ignition timing advanced for cylinder number 1. So if you look at our fuel trims, right now they're at 13%, which is not good. It's supposed to be around 0. The mass airflow is about 2.5 grams per second. It's a 2.7 liter engine, so that's pretty close. So let's rev it up a little bit. See, the fuel trims are definitely kind of high. So another variable here is that we either want to confirm or or not confirm, is the timing chain. The timing chain tensioner is getting a little rattly again. If you remember, we replaced it at 130,000 miles, and it's been fine since then. Now at 170,000 miles, it's starting to rattle a little bit when the engine's hot, at a hot idle. So is it possible that this cam chain is stretched, causing everything to be retarded, and basically the engine's not breathing right, and you know, you get fuel trim problems, power issues. You know, the mass airflow is only 2.5 grams per second right now. Maybe that's a little low. So let's jump back into that test. Actuator test, fixed spark control. Again, custom list, RPM, airflow, long-term, and let's graph ignition time. Okay. So when I hit on, this thing goes to 5 degrees, fixed timing, and if you look at our harmonic balancer, that white mark is still way to the left of the timing cover marks. It's at like, I don't know, about 20 degrees before top dead center. It's fixed, but it's not at 5. It's like 15 degrees out of spec. Now, a few years ago, I actually advanced the camshaft position sensor just to get more power, and it worked, but something's still not right. So first thing I want to do is confirm that that white mark is indeed TDC of number 1, so we're not chasing ghosts. And then we can use a pressure transducer in cylinder number 1 and do 2 channels, the spark and TDC number 1, and see if, you know, how many degrees on the pico that's occurring, to verify what we're seeing here. Then we can tweak the spark timing, see if it does anything, and kind of make heads or tails out of this. And also on the pressure transducer waveform, we should be able to see if the valves are indeed, the valve timing is getting retarded, and how many degrees. We'll go from there. First, let's pop out this number 1 ignition coil. And the spark plug. Now the spark plugs here I have not touched since I bought this vehicle. It had 80,000 miles on it, now it has 170. These NGK iridiums show no wear, so I haven't replaced them or anything, which is amazing. These are still, might be the original plugs. So now that we have the spark plug out, I'm going to put a wrench on the harmonic balancer, turn it, and put a rod in the cylinder. Make sure we're at TDC when that white mark aligns with the timing cover. So I have a little piece of brake line placed in the spark plug hole, and it's touching the actual piston. And as I turn the harmonic balancer here, we'll see where TDC is. You can see it's rising out. Whoops. Let's see. Still coming up. Right about there. And indeed, the little white mark is exactly at 0 degrees right now. So right there is 0. We're definitely at TDC. As soon as I turn the wrench a little bit more, that rod will start to go down. Okay, so I believe the white mark. So our ignition timing is definitely way over advanced. Now I want to put an in-cylinder pressure transducer in here and unplug the fuel injector. Do the same test with 2 channels. We'll put a current clamp on here, and then we can tweak the the camshaft position sensor and see if we go by spec, 5 degrees before top dead center, what that does to our power and our fuel trims. Alright, so here's the setup. 2 channels. Channel 1, the PHAD homemade pressure transducer, and our amp clamp on the 20 amp scale. 1 volt is 10 amps. Obviously we want to re-zero our amp clamp. There we go, it's 0. We're showing 0 psi. These are custom scales, so this goes from 0 to 130 psi. We're just running it at idle. I made several custom scales here. You can go all the way down to -20 to 80, -15 to 135, and then -25 to 225. This transducer is a 200 psi unit. So let's try the middle scale. Let's fire it up. See what happens. Make sure my laptop is steady. Okay. Obviously a misfire. You got the spark jumping right there. Pause it, see what we have on our transducer. So our current is going the other way, so we can just flip the amp clamp around. I guess that's the power wire, not the ground, but it doesn't really matter. Okay, go back to 100. Okay, now we're right side up. And what happened to our pressure transducer? Okay, there's our waveform. You do a snap throttle. Okay. Now, let's do the fixed spark. Okay, we'll let the engine warm up a little bit more. For now, we can pause and zoom in. You can actually see where the spark is occurring right now. Let's put in some cursors. So we go to rulers, 4, okay. So let's say that's 0 degrees. That's 720. Now, from there to there, delta is 23 degrees. Okay. Alright, engine's warmed up. I got it activated for 5 degrees before top dead center. Verify with the timing light. It looks like we're about 20 degrees before top dead center. And on the scope, I'm rolling. So let's pause that. Zoom in. Make sure our cursors are right at TDC. Right. See there. So we're shooting about 14 degrees before top dead center. It should be 5. Yeah, I guess that's believable. So what if we right now move this cam sensor to make that white mark line up and do the check again. Alright, so I loosened up the pinch bolt for the cam sensor and I put a white line right where it is right now. So camshaft's turning this way. We want to retard it a little bit to get back into spec. Like that way. Let's go back to our timing gun. We're still at 5 degrees. So our mark is at about 15 degrees right now. We gotta keep going. So we're at about 10 degrees right now. Man. One, two, three, four, five. Okay, right there. That's spec. So tighten the bolt down. You can see how far advanced I had it. And now, we run the scope. Pause it. Zoom in. You can actually see by the scope our ignition is actually occurring after top dead center now. So the timing gun might not be the most accurate way to do this, is set a trigger. A channel B. Where's our trigger? To 100%. And then knock down our seconds per division here. Now when we move the cam sensor, we'll be able to see the actual relationship. So that's 720. Now, to zoom in, we want to be 5 degrees. We want the ignition to occur right there. Okay? Alright, so now I'm going to advance the timing. And look at that red trace. Okay, so the trigger we should have set to the falling edge. There we go. And now We're almost there. A little bit more. About 5 degrees. And what does our timing gun show? About 12 degrees. So what's the discrepancy from? Is this not really TDC according to the pressure transducer? Okay, so now we have the same experiment set up on cylinder number 2. And we could do the same fixed spark. Now start it up, put it into fixed spark mode, and see if this one is 5 degrees off, or if the timing chain is stretched and the ignition timing is off of this bank, and if the actual mechanical valve timing is off, well, what do we expect? TDC should still line up, but maybe the peak pressure will be a little different, but let's give it a try. Alright, I got it in fixed spark mode. We're at 5 degrees before top dead center. So let's look at cylinder number 2. Set up our rulers here. Right around there. That's showing 8 degrees before top dead center. Well, actually, okay, 6 degrees. So not much difference. 5 degrees before top dead center. So between bank to bank, it seems consistent. Now that's good. What about the waveform as a whole? Again, very similar. Our peak pressure is about 42 psi. And valve timing, again, looks very similar. Is this a no good? Hard to say. But at least we have the data. We'll take it for a spin with this ignition timing, calculate the miles per gallon, and see where it goes. But hey, your own vehicles need some attention too. This truck has treated me really well. It's gotten me through a lot of things. Reliable, and I want to keep it that way. So thanks all for watching. Stay tuned for part 2. There's an update, but at least we figured out how to check ignition timing, verify it with a pressure transducer, use a timing gun on a new school system, and yeah, always learning every day. So thanks a lot for watching, and see you next time. Bye bye.